Hi children, good morning. This is your Tajari Sir, Maths teacher. In yesterday's video, we have discussed the introduction part of set, and we hope that we complete that exercise 2.12. Now, today we are going to discuss about types of sets. The types of sets, the first one is empty set. Its name gives the clear idea that it is empty. Empty means what? Nothing. A set with no elements is called an empty set. Now we have a doubt whether such sets are there. Yes. Once see, suppose if I am taking a set such that x is a natural number less than 1. Here A is a set of x such that x is a natural number less than 1. Less than 1. So, is there any natural number which is less than 1? We know that there is no natural number which is smaller than 1. So, this set is an empty set. I hope you understand. So, empty set means a set without any elements. This we will represent an empty set by a set without any elements, or we have another symbol which is read as 5. This is a notation for an empty set. That means in this set there is no element, so we can write either a set without any elements or we can use the symbol 5. This is about the empty set. The second one is Singleton set. Singleton set. It is also, and the name itself giving an idea that it is a single. That means a set with only one element. A set with only one element. Is called a single set. Singleton set. Such a set we have is, for example, if I am taking a set P is equal to set of x such that x is an even prime number. Even prime number. So remember, what is the even prime number? We have, there is only one prime which is even, that is 2. So the set 2 is even prime number. So this is a singleton set. So an empty set means without any elements. Now I have a doubt whether a set with an empty set is an empty or not. A set with an empty is an empty set or not. To understand this, I would like to show an activity. See here, this is a box where nothing is there. That means it is empty box. And this one also an empty box. In this also nothing is there. Now an empty box has this another empty box. Now tell me, is it empty? So surely it is not an empty. That means a set contains an empty set is not an empty set. So this set it is not an empty set. Similarly, and a set of 5 is also not an empty set. Finally, set of 0. Here it is also not an empty set. This set has an element 0, which means this set is also not an empty set. So I hope you clear about this. A set contain an empty set is not an empty. And next one is our universal set. Universal set. Universal set means a set. Suppose we are taking some sets. Suppose I am taking yesterday's video, that is set of vowels. We took vowels from where? From English alphabet. So the English alphabet, the set of English alphabet is an universal set. From that we took the set of vowels and consonants. So here the universal set means a set contains all the elements. A set contains all the elements. From the set we are taking our required sets. Suppose if I am taking a set of even numbers. Set of even numbers. So what are the even numbers? 2, 4, 6 and so on. Similarly, odd numbers. That means 1, 3, 5 and so on. These even numbers and odd numbers, from where we took, it is from natural numbers. So natural numbers means odd numbers and even numbers together are known as natural numbers. So here this natural number is the universal set for even numbers and odd numbers. So I hope you are clear about this concept. So universal set means a set contains all the elements where these even numbers and odd numbers are took. So these natural numbers here act as universal set. Usually universal set are represented by capital U or mu. Now the next one is subset. What is meant by subset? Suppose A, B are two sets. If all the elements of A are in B, then we will say A is subset of B. If all the elements of A are in B, then A is said to be subset of B. We will denote by the symbol like this, and we will read as A is subset of B. To understand this concept, I would like to explain by an example. So A is equal to A, E. B is equal to A, E, I, O, U. Now here you can observe clearly that every element of A is a member of B. Every element of A is a member of B. That means A is subset of B. So subset means a set, if A, B are two sets, if all the elements of A are as a member of B, then A is said to be subset of B. Okay, now the next one is every set is a subset of itself. Every set is a subset of itself. For example, if I am taking A is equal to set of 1, 2, 3 and B is equal to set of 1, 2, 3. Now here all the elements of A are in B. Is it not? That means A is subset to B. So you can observe that both the sets are same. That means they are not only subset, they are also equal. Which means every set is subset of itself. Because of A, we are an equal set. So here every set, so which implies A is subset or equal to A. Because of A and B are equal. So every set is subset of itself. And the second one is empty set is a subset of every set. Now here we have got it down. Empty set doesn't have any elements, but it is how it is subset to every set. So we are thinking about pi is, so which means pi is subset of A. All the elements of pi are in A, so that pi is subset of A. It means. But we know that empty set has no elements. Then how it becomes a subset of A? Subset of every set. I will explain by an example. Suppose, what is meant by pi? It is an empty set. Empty set means nothing. And if I am taking a set 1, 2, 3, first 3 natural numbers. Now, so the A set has what are the elements? 1, 2, 3 and nothing. And nothing. Because of after 1, 2, 3 number there is no elements in A. That means nothing is there. So which shows that pi is subset of A. Empty set is subset of A. I would like to explain by another concept of subset. What is that? Here we know every element of A is in the second set, then the first set is subset of the second one. Suppose here I would like to take A is equal to 2, 4, 6 and B is equal to 1, 2, 3, 4, 5, 6. Now one thing, in another way we can say the subset like no element of B is in A, then A is not subset to B. No element of B is in A, then A is not subset to B. Which means, suppose in A, if we have 7, this 7 is not in B. That means A is not subset to B. So which gives that if no element, that is every element, not I am saying, see, normally A is subset to B means every element of A is in B. Now I am telling that no element of B is not in A. No element of B, that means the element which is not in B, that is not in A also. Which means A is subset to B. No element of B is not in A, so that A is subset to B. Now if I remove one element, now no element of B, that is other than the elements of B, is it any element in A? No. That means still A is subset to B. Now no element of B is in A. Is there any element which is not in B that is in A? Still it is not there. That means A is subset to B. Now no element of B, that means the element which is not in B, is it in A? No, that means A is subset to B, which gives an empty set is subset of every set. Empty set is subset of every set. So by this what we can conclude, every set is subset of itself and empty set is subset of every set. These two things we understood. Now coming for the next topic, number of subsets we can frame for the given set. How many subsets we can frame for the given set? Now here we have one set A, B, C, 3 elements. Now how many subsets we can frame? First one is empty set is subset of every set. And next one is set of A. So this is subset of the given set. Like this only set of B, set of C, set of A comma B, set of B comma C, set of A comma C. Is it completed? Still one more is there. What is the set itself? That is set of A, B, C. This is also subset. So here we can find the number of subset for the given set. How many subsets we have? 1, 2, 3, 4, 5, 6, 7 and 8. So total 8 subsets are there for the set has 3 elements. If I am taking another set A, set of 1, 2. How many subsets? Subsets of A. First one, empty set is subset of every set. And the set itself is a subset. So A is a subset of itself. Instead of writing set of 1 comma 2, I just mentioned as a set A. Now set of 1, set of 2. So here a set has 2 elements, and how many subsets we have? 1, 2, 3, 4. 4 subsets are there. In my first video I told you the number of elements in a set is known as it's a cardinal number. Suppose if I am taking this set as X, then number of elements in X is 3. Here the number of elements in A is 2. Now how many subsets we have? 8 subsets when a set has 3 elements. Here the 4 subsets. Here 8 we can write as 2 cube and 4 we can write as 2 square, which means we can generalize the number of subsets of a given set by, see here 2 elements, so that the number of subsets are 2 square, and 3 elements we have 8, that means 2 cube. Here the exponent of 2 is represents, gives the how many elements in a set, and the base is 2 is fixed. By this we can generalize the number of subsets of a set with n elements is 2 power n. Here n means number of elements in the set, and 2 is 2 power n gives that number of subsets of a set. Okay, proper subset. So what is meant by proper subset? The sets which have at least one element smaller than the given set. To understand this concept, I took another example. P is equal set of x comma y. The subsets of P, as we know before, the empty set is subset of every set, and set of x, set of y, set of x comma y. Among these subsets, this set is equal to the given set. That means equal number of elements are there to the given set. But the other sets are less than the elements of the given set. So these sets are called proper subset to the given set. Here the proper subsets of a set are empty set, set of x, set of y. So this is a proper subset. So proper subset means the sets which have at least one element lesser than the given set are known as proper subset. So I hope you understood the example.